Hello everyone, now I will demonstrate task 2, conducting TDD unit testing activities using Python. We need to implement the function pointIsInBox, which determines whether a point is inside a given rectangular box and return true or false. I will do 3 test cycles. Each round follows TDD write a test to make it fail, then modify the code to make it pass. And I will use graphs to display the points and rectangles for easy explanation. Now I fix a rectangular example. The top left corner is at 1020 with a width of 10 and a height of 8. X range 10 to 20 and Y range 12 to 20. I write a function that draws a rectangular border in the positive of the current test point each time. I also draw 4 dashed lines to represent the boundaries left, right, top, and bottom. This way, you can immediately see whether each test point is inside, outside, or on the boundary. I also write a run test function that prints the expect and actual values for each test and marks it as pass or fail. We start the cycle 1. In the first round, I start with the simplest scenario, a point inside a rectangle. I choose the test point 15, 16. First, look at x equal 15 falls between 10, 20, and y 16 falls between 12, 20. So this point is completely inside the rectangle, and the expected result is true. Now I'm writing test 1 and the expected result is true. According to the TDD rules, I first write the simplest stop function vision v0. v0 directly returns fails. So test 1 will definitely fail. Next, I made the smallest changes to get test 1 to pass. I will first implement the x direction check. Left less than equal point x less than equal right. This way, the point x of test 1 is within the range, so it returns true, and test 1 becomes pass. But I emphasize that v1 is not complete because I haven't checked y. In the next round, I will add a new test case that causes it to go out of bounds in the y direction, forcing us to improve the function. In the second round, I test the outside scenario. Click outside the rectangle. I specifically chose the point 15, 25. You see that is x equal 15 is still within 10, 20, but y equal 5 is already above top 20. So the point is above the rectangle, so it should return fails. The reason for this choice is that v1 only checks x, which will cause it to be misclassified as true, so we can see the test fail. Now I run the test 2, and the expected result is fails. Run the order vision v1 first, because v1 only looks at x and returns true. This will fail. This is the key to TDD. Failing test point out that we are missing the y-axis judgment. Now I have upgraded to v2 and added the y judgment. The legal range for y is from bottom equal top minus high to top. That is bottom less than point y less than top. At the same time, the x direction is also left less than point x less than right. I deliberately use structure less than and more than, only ensure that points in the true interval are true. This way, test 1 inside should still pass. Test 2 outside should also pass because y equal 25 is not in the range. After running, I can see test 1 pass and test 2 pass. However, because I used the structure comparison, points that fail exactly on the boundary, such as x equal left or y equal top, are considered not inside. So in the third round, I will use the boundary points to drive the final version. Third round test boundary, the point is on the rectangle boundary. I chose the point tan 16. Here x equal tan is exactly equal to the left boundary, y equal 16 is still between 12-20. The question usually counts the boundary as inside, so the expected value is true. But our current V2 uses the structure listen, which would execute x equal tan, so it should fail. Now I run the test tree. The result will be fail, which means we really need to include the boundary. Now I'm writing the final version V3. Change the judgment to left listen equal point x listen equal right. Change the judgment to bottom listen equal point y listen equal top. This way, the inside point is still true. The outside point is still false. Boundary points are now also true. I reran test 1, test 2, and test 3, and all 3 tests passed. This completes 3 rounds of TDD, 1 new test per round, failing first and then passing. Graduation refining the implementation. Finally, I will briefly elevate the experience of TDD. I think the benefit of TDD is that the goal is very clear. Added only one minimal test at a time, allowing the implementation to grow incrementally as needed. It also prevents me from writing too much logic at once and making mistakes, because every step is tested and the regression tested. The downside is that it can seem slow in the beginning because you have to write tests before you write the implementation. However, it can significantly improve code correctness and maintainability, making it particularly suitable for functions like cohesion detection where logic is prone to boundary issues. Thank you, that's all.